So we're going to look at a fairly common task that we're given to do here when it comes to binomial expansions and talk about why it would be inefficient to use Pascal's triangle to do so. But it says use the binomial theorem in order to find the desired coefficients. And all we want to do on this problem is find the coefficient of x to the fourth in this expansion. So you'll notice that we're expanding this binomial, but we're expanding it to the 12th power. So like if I were to actually, do this here, I'd have to write out, well, it'd be, 2x to the 12th plus, 2x to the 11th, times negative 3 to the first plus, 2x to the 10th times, negative 3 to the second, and so on and so forth. And then you would actually have to go through and find out actually all this other business here. So what I can tell you is I can make your job a little bit easier here, but we have to use the binomial theorem to do so. So when I talk about use the binomial theorem, this is actually the first video that I'm really kind of clearly pointing to this thing right here and saying that what this does is it represents this entire finite sum right here, starting at a r value of 0 and going up to an n value here. So you'll notice that we say what that does is it really does represent a plus b to the n power, where n is actually the power that we are raising this to, okay? But let's kind of pick apart what this is really saying. We say starting with r at 0, and we say r actually represents this exponent right here, which is an interesting thing. And we also have n choose r out front. So this thing right here, in terms of what we're doing for the sum, is we're going from r equals 0 to n of this rule, okay? And what this is the rule for the nth term in the sum. So when somebody asks me to go say, go find the coefficient of the x to the fourth term in this expansion here, what I'm going to do is I'm actually going to go look for that nth term in this expansion and point it back to kind of this thing right here, where I could say, well, the things I'm going to need to know are a and b. I'm going to need to know n, which is the power that I'm raising this to. And I'm going to need to know n choosing r at a time. And r is going to be the biggest battle in this entire thing right here. So here's the first thing I want to do, and kind of point towards some more easily found things. It says go find the coefficient of x to the fourth in this expansion. The things I want to write down first are these. We say n, a, b. In this case, I'm going to amend an r. So this is nothing different than what we've done up until now. But what I could say is this. In this expansion, we say our n here, our n, this is this thing right here, our n is 12. So we are expanding this to the 12th power. Now as far as our a and our b go, we say these two terms in the binomial, order matters here. We're going to say that our a value here is like 2x and our b value here is negative 3. So we're going to say 2x and negative 3 are these things right here, okay? So what we need to do is determine now what r is, and I'm actually going to come back to that. What I want to kind of point out is this. If this was x to the fourth, okay, and I'm going to binomial expand this, and I just want to pick on this one term, okay, and we say that the nth term is always n choose r, a to the n minus r power, times b to the r power, and I'm just getting this from over here. This is the nth term. Then what we're going to need to do is find all these things. So all I'm going to do is I'm going to fill in a 2x right here for my a. I'm going to fill in a negative 3x for this, and I'm going to say, okay, well, negative 3. I don't know why I put a negative 3x there. This is negative 3, folks. Yes, sorry about that. Negative 3. But essentially, what I'm going to do is I'm going to put these up here such that I would get an exponent, or sorry, a variable of x to the fourth. So what could I put, right here to give me x to the fourth? Well, this is going to have to be a 4. And now the thing I want to point out here is this. If this were a 4, what would this other exponent have to be? And the one thing I know is this. This 4 times whatever this is right here has to add up to be n. And the reason why is because in general, look at these powers here. We say that n minus r and r. When you add n minus r to r, you just get n. So this is going to have to be an 8 here. Okay. So here's the other interesting facet of this. But we said that this first part here represents n minus r, and this last part represents r. So essentially what I'm going to tell you is this. Whatever this number is right here, it's your r value. And we're going to need this because the last thing we need on this binomial expansion is what the coefficient of this would be, which is n choosing r at a time. So what we're going to do is we're going to say our n in this case, which was 12, we are going to choose the r value. And like I've said here, we say that this is n minus r on this exponent here. This is just r. This is always going to be your r value is the second exponent. So we say 12 choosing 8. So here's what we get to go do now. We say it's 12 choose 8 times 2x to the fourth. So I'm going to go ahead and do 2x to the fourth. I get 16x to the fourth, of course. And we say negative third to the eighth power. Now, off the top of my head, I could probably get this. but we say negative third to the 8th power, we say 3 negative, and we raise this to the 8th power. We should get a positive output, and 65, 61. Okay, so we say 65, 61. So you can see how this binomial expansion is going to have a monstrous coefficient because we still haven't even done the 12 choose 8 yet. So if we're going to do 12 choosing 8 at a time, what we end up with is this: 12 factorial over 8 factorial, of course, so this is going to have to be a 4 factorial, which is really 12 times 11 times 10 times 9 times 8 factorial over 8 factorial 4 factorial, where the 8's cancel out, and we're left with this. We get 12, 11, 10, 9 over 4 times 3 times 2 times 1. The 1 doesn't matter. 2, I suppose we could slice 2 and this 12 here, make this a 6. 4 would go, I suppose, 4 would have been a better candidate for 12 now that I think about it. We say 4 and 12. We'll call this 3 and 1. And then we say 3 and 9. I suppose we could call that 3 and 1. And then 2 and my 10. This is a 5 and 1. So 1's left in the basement, but on top we get left with 3 times 11 times 5 times 3. So 33 times 15 on top. So we get 33 times 15, which is 495. So that's just now the value of our combination. So we get this, really, this term would be 495 times 16x to the 4th times 65, 61. So we can see how it is necessary to use a calculator on this. We say 495 times 16 times 65, 61. And if I've done my calculations correctly here, 495 times 16 times 65, 61, I'd like to double check, I get this value right here. So we get 5196, 5196, 3120, 5196, 3120, x to the 4th. So to answer this question, we say that this would be the coefficient of the x to the 4th term. Okay, so again, we just identified n, a, and b, and then we just said, okay, well, if I wanted x to the 4th, and this is my a, and this is my b, then this would have to be a 4. And if that's a 4, this has to be 8, because they add up to be 12. And then we just get 12 choosing the r value, which is always this. This is going to help you find your coefficient. Cheers.